Okay, we have another integral from Columbia Integration Bee 2024, number 24. We have the integral from -1 to 1 of 1 plus cube root of x all cubed dx. Okay, I'm definitely thinking about even and odd functions here. We have symmetric bounds around 0. We have some odd functions, or we have odd exponents. But 1, even though it's an odd number, it's not an odd function, so it's not quite as simple. I don't know, I didn't do this one out on paper, so I'm actually thinking about it on the fly. What if we expand out this thing with a being 1 and b being the cubed root of x? So if we were to expand this out, this is just a cubed plus 3 times a squared b plus 3 ab squared plus b cubed. So then just plugging into this formula, when a equals 1 and b is the cubed root of x, then a cubed is going to be just a 1. I mean, all the a's are going away because it's 1, so this becomes 3 times cubed root of b here. Then on the next one, it becomes 3b squared. Ooh, that's ugly. That's going to be cubed root of x squared. I can write it that way. And then b cubed, that's nice. That's going to be just an x. Sorry, that should be a, sorry, that's an x right there, not a b. Let me clean that up. And then what that's going to allow me to do, I can split this up into two integrals. One is going to be the odd part and one's the even. So this here is an odd function. Cubed root on x, that's odd. This is going to be odd. This is going to be, let's do a different color. This is going to be even right here, and this is going to be even. So I'll do two integrals, one for the odd, one for the even. Okay, so now we're all set up to use our principle of odd and even functions. Again, this first one is going to be even. Let me just label that. This one is going to be an even function. And then over here, this is going to be an odd function. Both of these pieces separately are odd. So the principle we have for odd functions for symmetric bounds around 0, like we have here, is the whole integral is going to be 0. So we can just make this part go away and just focus on our even integral. And then next, our principle for the integrals of even functions for symmetric bounds around 0 says we can just change the lower bound to 0 and bring a 2 out front. But then from here, all we need to do is power rule. On this right here, I can write this as x to the 2/3 in order to make it easy. So we'll go ahead and integrate. We have the 2 out front. Integral here is just going to be an x. We're going to have a 3 in front. Power rule on this becomes x 5/3. Take a reciprocal. We multiply by 3/5 in front. Just evaluate this from 0 to 1, but clearly the 0 values are going to be nothing as we have x in both terms, so that goes away. Plug a 1 in, we have 2 out front. This becomes 1. This part just becomes a 1. Multiply this, we get 9/5. If we have a common denominator here, write this as 5/5, this becomes 14/5. Multiply it out, for my final solution on it, we just get 28/5, and that's it. Okay, there you go. Quick one from Columbia 2024. Thanks everyone for watching. Have a good day.